When we talk about the cardiovascular system, we always talk about blood pressure, right? But what exactly is our blood pressure? Remember that inside of the cardiovascular system, right, the blood vessels are essentially just tubes inside of the body. And it's inside of those tubes where we have all the blood. That's a fluid. Now, that fluid is going to exert a force on that vessel wall. So if I sort of blow this up and make it a little bit less dimensional, right, that fluid exerts force on that wall, right? And so that force is what we refer to as blood pressure. So in other words, our blood pressure is equal to the force exerted on the vessel walls. So force exerted on the vessel walls. So if we look, remember that when we looked at the cardiovascular system, we had blood flow throughout the circulation and we had our arteries, right, starting with the aorta. We had our arterioles. We had the capillaries. We had the venules, and then we had the veins, ending with the vena cava. Now, remember that during the cardiac cycle, the ventricle is going to pump blood into that aorta, so that when we pump more fluid into that vessel, that force is going to go up. And then as the ventricle starts to relax, that pressure is going to start to drop, and then we'll pump more blood back into it. So it will rise back up, and then it will drop. Okay? And so what happens is you get this pulsating sort of graph of the pressure. It goes up, then it comes down, then it goes up, then it comes down. Right? And as we move away from the source of the pump, that sort of pulsation goes down, and as we move further and further away, the pressure decreases. Okay, so what we can then measure is we can actually measure this force against that wall. And when we do so, we always measure our blood pressure, our BP, as systolic pressure over our diastolic pressure. Okay, and so the systolic pressure is when the ventricle is actively pumping that blood into the arteries, right, during ventricular systole. So this is my systolic pressure. Okay, so that is my systolic pressure. I'm going to get rid of this. Okay, so now that we have our systolic pressure, right, what we're going to do is we are going to measure the force when the ventricles are in diastole. So this is my diastolic pressure. Okay, so the systolic pressure, that top number, that's the pressure that is on those arteries when the ventricles are actively pumping blood into those arteries. And then the diastolic pressure, your bottom number, is the pressure on the vessels when the ventricles are in diastole and blood is not actively being pumped into the vessels themselves. And the difference that we see between the systolic and the diastolic, right, this difference here, that's what we call our pulse pressure. Okay? So that's the pressure difference between the systolic and the diastolic pressure. Right? So how big of a difference is that? And when we look, a lot of times what we will use when we measure our blood pressure, we use something called the mean arterial pressure. You'll see this abbreviated MAP, mean arterial pressure. Okay, so that mean arterial pressure is the average pressure on the blood vessels during the entire cardiac cycle. Now, you might be quick to say that, well, we just take the systolic and the diastolic and we average them, but that's not how it works. The mean arterial pressure is our diastolic pressure. So it's our diastolic pressure plus 1/3 of the diastolic plus pulse pressure. Okay, so why is it not sort of the mean between diastolic and systolic? Right? Well, it is the diastolic, so our mean arterial pressure, let's make this one purple. Our mean arterial pressure is that diastolic plus 1/3 of the pulse pressure. So our mean arterial pressure then sets about there, right? It's closer to the diastolic pressure. It's not the middle between systolic and diastolic. It sets closer to the diastolic pressure because the heart, the ventricles spend more time in ventricular diastole than they do in systole. It's not an equal amount of time in both of those. So because the heart spends more time in ventricular diastole, the mean arterial pressure, right, is closer to the diastolic pressure. And that, right, that blood pressure, remember, is the force exerted on those walls. So when we talk about blood flow through our tubes, right, remember we have a pressure here. That's that pressure that we're talking about, right? And we have a pressure down here. Okay, so those pressure differences that we talk about, right, remember that is our perfusion pressure. And that perfusion pressure will start to have implications on blood flow through our tubes or through the circulatory system.